So this should be the last video in this pre-lab for Lab 3. And so we're talking about collecting motor speed data at 50 Hertz sample rate. So that's every 20 milliseconds. You want to read the VEX encoder and then do a calculation to determine the motor speed in RPM. And you'll plot this data out in RPM versus time in seconds. So it does describe here. You can either just do a serial print to the window and copy and paste it. You want to separate the data with commas, or you can use putty right here, and you can go to this wiki. It explains how to do that. Okay, and then just make some observations. Does the velocity stay constant? Would you expect it to stay constant? In terms of, we're talking about the rotational velocity of the crank. So in other words, suppose the friction is as this angle of the coupler changes. Is that going to increase the friction? Would you expect the velocity to stay exactly steady or not? So you can think about that. And the next part of the lab is you're going to set up external interrupt function that increments. So maybe you have count, or call it whatever you want. And anytime there's a rising edge on Arduino pin 2, it increments the count and then also prints out a timestamp using micros. So again, you can collect. This is fairly easy to do. And then you want to use in the function generator input a 50 Hertz square wave and save the terminal output for 1 second, and then plot the sample count versus time. So again, you can use putty if you want, or just do a serial print and then copy and paste with that. Next, you're going to generate a 50 kilohertz square wave without using a timer library. Okay, and then use the digital write function and the delay microseconds function. You're going to have a 10 kilohertz PWM signal. You want to see how small of a duty cycle you can achieve, how small of a non-zero duty cycle you can achieve using these functions. And then part C, you'll use the analog write function. So of course, analog read, if you read one of the analog pins, excuse me, that gives you a number between 0 and 1023. When you use the analog write function, you're actually writing to a digital output. It has to be one of the PWM capable digital pins, but you write to that with a number between 0 and 255. So the question here is, what is the smallest possible non-zero duty cycle that you can achieve? Now, depending on what pin you're looking at with analog write, by default there are certain frequencies on certain pins, so you're going to have to do some research on that. The analog write function, in other words, by default is going to have a certain period for its PWM signal, and then servo.write, that when we use the servo class, that has its own period, which is different from analog write. So you may remember that off the top of your head, but how that works, and also how the the range of duty cycle that you can put into the servo.write, or what it creates. And then the next step here, you want to use timer interrupts to try and create this PWM signal and see what's the minimum step that you can achieve. And we talked about Brad Miller came to class and did a lecture on Bluetooth, and the protocol can be found on the final project page, and he'll be at the lab, and we'll be working on doing these items here during the lab. So that's it for the pre-lab for Lab 3.